force. So what is force? Force is, first of all, you should know that force is a vector quantity. Okay, it is a vector quantity. That means it should have both magnitude and direction. Okay, it has both magnitude and direction. So regarding the force, I should know what is the force first of all, and then what is the magnitude and what is the direction. Second parameter regarding the force, you should know that nature of force, what is the type of force. And third parameter regarding the force, you should know about the point of application. Point of application. That means at which point the force is being applied. So these are the three major points that you should know whenever you encountered any type of force. So in nature, different types of forces are there, but I should know for any type of force, I should know that what is the magnitude of that force, what is the direction in which that force is acting, what is the nature of that, and what is the point of application. Now regarding the point of application may not be so much important right now, because I can give one example. Let us say there is a object resting on a floor like this. Okay, we apply it. Now what is the unit of force? Unit of force is Newton. Unit of force is Newton. So if I apply, let us say a force of 10 Newton on this particular point, at point A, then I observe that the body will translate and it goes to this point. Okay, to this place, let us say. Okay, if I apply the same force on this point, let us say at point B, I am applying this force of 10 Newton, then I can observe that the body will tilt like this. When like this? Okay, ultimately the body will fall. So in both the situations, the point of application is important. I am applying the same magnitude of force. What is the nature of force? Pushing type of force. I am applying a pushing force at point A or at point B, but depending on the point of application of force either at point A or point B, the behavior pattern will entirely change. Either it may translate or it may fall. Okay, that's why the point of application is important. But right now, whatever the force that you are going to apply on a particular body, so regarding the body, what we consider that body is the object that on which I am applying the force. So it should be have a point. Point object. What is the point object? Point object means the dimension of the object is not there. Okay, if I say this is the point on which I am applying a force, so I cannot say that at point A I am applying force or at point B I am applying a force. Okay, so since point has no dimension, so regarding that, the point of application is not so much important right now, but later on I will understand the point of application is going to play a crucial role for the force. Okay, so now depending on the application of the force, there are two objectives. One is called the translation and the rotational motion. Okay. So whenever we apply a force, let us say there is a body on which I am applying a force, then the body may translate. Okay. So the body may translate along x direction or body may translate along y direction. Any direction the body may translate. Only thing is that the body will translate. Now, if the translation is there, then it is linear the translation motion. If I apply suppose there is a wheel on which I apply a force in this direction. Now, because of this force, the wheel will try to rotate in this direction. Okay. So there is a possibility that the wheel may translate as well as rotate. So the body may be either rotational motion or the body may be under the translation motion depending on the force that I am applying. So there are two effects of force. And if for a particular situation, for this situation, let us say I am applying a force, the body or the wheel will translate as well as rotate. Okay, so when both translation and rotation are taking place, then it is called the transrotation motion. Transrotation. Okay, so transrotation is a phenomenon when both I am saying that translation as well as rotation are taking. So all are the application of force. Until and unless I apply a force, the body may not translate. Until and unless I apply a force, the body will not rotate. Once I apply a force, this kind of possibilities are there. Okay. So when a force acts on a stationary rigid body, so rigid body means what? Rigid body means there is no deformation. No deformation. So if I apply a force on a body, then the effect of force is that may deform the object. Let us say I take a substance made of clay. Let us say a substance made of clay. So if I apply a force on this body, then the clay will deform like this. So this deformation is permanent. This deformation is permanent. So if the deformation is taking place, that means this body is called the non-rigid body. Non-rigid body. Okay. So if there is no deformation, that means I am saying the body is rigid body. And for all of this situation, I am going to taking the body to behave as a rigid. That means there are some other bodies also which are non-rigid in nature also. Okay, rigid body is an ideal concept. So in universe, there is no such body which is acting as a perfectly rigid. Whenever we are applying a force on a particular body, the body must be formed. Okay. Now the body starts moving in a straight path. Whenever they are moving, it is moving in a straight path along the direction of the force. Then only I can say it is a translating motion or the linear motion. This is called the translation linear motion. Let us say I am pushing a ball. Now this force is applied at a particular point A. Now this point A is always passing through the center of the ball. Okay. That means this force has no effect. That means it can turn the. Okay. So if I apply the same force over here, let us say at point B. Now B at some distance above the O point. Now this force has the effect to produce the rotation. Okay. Whenever I apply a force which is passing to the geometric center of the body, then that particular force is always going to give the displacement along the direction of the force. That is, it is a translated motion. Okay. So pushing a ball lying in the floor. When we apply the force, that means the body will try to move. And it will move along the direction of the force. So in which direction you are applying the force? Along that direction the body will move. Tendency of movement of the body should be along that particular direction. Okay. Like this way, the body is moving along a straight path. The car is moving along a straight path. So that means it is moving along a straight path. So I can say that the path is straight line. That means it is performing translatory motion. Okay. Now, so in order to move this body, there must be some kind of force is acting. Now, who is giving the force? In this situation, the automobile engine is there, that is producing the engine force. So, engine is driving the car. Engine is pulling the car. So, we apply a force on the particular body. Because of that, the body is moving. Okay, and body is moving in a particular straight line. So that I can say this part of the translated motion. Now, I apply the force at a different point. Let us say I am applying a force at this B point. Now, this B point is not, the force is not passing to the center of the point. Center of the wheel. So the point where the wheel is being pivoted. Pivoted means the point at which it can rotate. Okay, I have to fix this point. So once I allow the force to pass to a point which is not passing to the point O, then the wheel will rotate. Okay, and this is called the turning effect of the force. So this force is used to produce the turning effect. Because of this force, the wheel will rotate. Let us say I am saying this is the body. This is the body. So this is the O point. I am applying a force over here. Here I am applying a force. Okay. So because this force is in the force, the direction of force is in this direction, so it is not passing to the point O. So there is a distance between these two force and the O point. What is O point? O point is the point. It's called the P point. And there is one point marked as P. So what is P point? P is the point where I am applying the force. Where I am applying the force. So there is a distance between O and P. So if the distance is non-zero number, then only it has the ability to produce the turning effect. Okay. So whenever once I see a turning effect of the force, then that particular force is responsible to produce the rotation of the body. That means it is the rotational motion. Okay. So in this situation, the body will rotate. Okay. It can have. It can. Because whenever I am saying a wheel is rotating, that means it should rotate either in clockwise direction or in anti-clockwise direction. Okay. Sometimes in clockwise direction, sometimes in anti-clockwise direction. No, it is also possible. That means you are going to change the direction of the force. If I pick the direction of the force is always fixed, then the direction of rotation is also fixed. Okay. So whenever I am yes, that may be there, but whatever the situation is that if I apply multiple, let us say there is an object on which you are applying multiple number. Let us say at this point I am applying one force of 10 Newton. Okay. At this point I am applying a force of here, it is 5 Newton. And at this point I am applying a force in this direction, let us say 5 Newton. Okay. So at different point A, B, C, I am applying different types of forces. Now overall effect is that it can produce the translatory motion, it can produce the rotation motion, both are there. Now for that what you have to say, you have to check the moment of force. Okay, I will discuss about that. If I get the moment of the force to be non-zero, that means the body will rotate. If I get the net force is non-zero, then the body will translate. Okay, so there are two parameters that you should understand. But first of all, you have to understand that body will rotate because of the turning effect of the force. So force has two types of effect. One is that it can produce the translation. Another is that it can produce the rotation. Whether it will produce the rotation or translation, that you have to decide depending on two parameters. Okay. So whenever a body is rotating, that means I should say there is a one axis about which the body is rotating. Let us say this wheel is rotating. So there is the axis of rotation about which the body is rotating. So let us say the body is rotating about this axis. So all the points on the body are moving. All the points on the body are moving. Only thing is that the axis point, let us say the O point is a fixed point. This point is fixed. Apart from O, that is the point which is lying on the axis, all the points are moving. And all the points are moving because of the effect of the turning effect of the force. Only one point is at rest, and that point rest is basically the axis. Okay, that point which is at rest is the axis. So if there is a fan which is not rotating, that means it is at rest. If the fan is rotating, that means there may be the rotating at a constant speed or maybe variable speed. Okay. So depending on that, I can say the angular velocity may be constant, may not be constant. What is angular velocity? Like the case of linear speed, let us say if I say there is a ball which is moving along a straight path with a velocity of let us say 10 meter per second. So this is called the linear speed of the body. Okay. If I say the body is rotating along a circular path with a speed of let us say 10 meter per second, then corresponding to this number, if I divide this number with radius of the circle, okay, radius of the circle, then I get the angular velocity. Angular velocity written by the symbol omega. So omega equals to what? V divided by. Okay, V divided by R. What is V? V is the linear speed and R is the radius of the circle. So if the omega is not changing, that means the particle is moving continuously with constant angular speed. Okay, then it's called the constant angular velocity. If angular speed is going to be changed, that means some kind of acceleration is there. Okay, like in the case the body is moving with the speed of u, and after some time, suppose you observe the speed becomes 20 meter per second. That means you can conclude that the velocity of the particle is going to increase. That means there is some kind of acceleration. Same is the case for the rotation also. In rotation case also, the body has some kind of acceleration. If the acceleration is there, then the acceleration has a symbol of alpha over. Okay, alpha is called the angular acceleration. Like here I write A. A is called the linear acceleration. When the translational motion is there, I say the body has linear acceleration of A. Where the body is rotating, then I should not say the alpha. I should say the alpha. Why? Because alpha is the angular acceleration. What is angular acceleration? Again, I divide A by R. Okay. What is A? A is the linear component. So whenever I divide the linear component by the radius of the circle, I get the angular. And these relations are related like this way. Angular component is basically the linear by R. Okay. So that is called the angular acceleration. So particle is rotating and continuously increases speed. This is called the angular acceleration. If the angular velocity is constant, that is no angular acceleration. Okay. So now we define at the movement. Now what is movement? Movement is basically the turning effect of the. Okay. So whenever I am applying a force, if that effect, that force is able to produce the rotational effect of the body, then I say the moment is. Now moment is defined by the symbol m vector, or I can write tau vector, called the torque. Okay, torque tau. So these two are also vector quantities. Similarly, the force is the vector. Now how it is measured? It is measured by the product of force and distance. Okay. So on simple way, I can say it is F into D, but there is another component like sine theta is there. But forget about the sine theta component. If I say that F into D. Now what is F? F is the applied force. F is the applied force. Now what is D? D is the perpendicular distance. Perpendicular distance. Perpendicular distance of what? Perpendicular distance between the point O. O is the point called the pivot, and P is the point through which the force is being acted. Okay. So P is the point through which the force is there. So between O and P, what is the perpendicular distance that you have to calculate? Let us say I apply a, so let us say with the body, I apply a force over here P. Here I am applying a force of P. At point P, I am applying a force. Okay. Let us say the point O is over here. Point O is, let us say, over here. Okay. Point O is over here. Now, what is the perpendicular distance? So, in order to calculate the perpendicular distance, you have to project this A or extend this F line, and from O, you draw a vertical or 90-degree angle line. Okay. Once I draw the perpendicular, so that is with the D. Okay. So that D is the distance of the point P from the O, and that distance has to be the perpendicular distance. Okay. So if I apply this concept of force with distance, where distance is the particular distance, then I get the feeling of torque. Okay. So now torque is a vector quantity. So this part will give the magnitude part, and whatever the direction. So you have to give the direction. The direction may be either clockwise or anti. How to calculate that? So for that, the simple rule is that, so you have to place your pencil along this force. So let us say I place my pencil or pen along this force. This arrowhead gives the direction in which the force is being applied. That is the tip of the pen. Okay, let us say you put the tip of the pen along the head direction, and the blue color arrow signifies the direction of the force or the direction of pencil. Now, what you have to do, you have to rotate the pencil, and you have to rotate the pencil so that pencil will be directed along the point 2. So one way of rotation, so that means you have to place the pencil in this direction, in this direction, in this particular direction. So if I rotate this along this direction, then I can make this angle. Okay. Or I can also rotate in this direction also. So in this situation, I have to rotate by 270 degree. And in this situation, I have to rotate by 90 degree. Okay. So I place the pencil along the direction and I rotate this pencil towards the O point. Once I rotate the pencil towards the O point, I have to cover 90 degree angle either or 270. So between these two, you have to choose that which angle is minimum. So I found that this angle is minimum. So that will be the direction of the torque. Okay, and what is that direction? That is the anti-clockwise direction. So this force is producing an anti-clockwise torque about point. So whenever you say torque, torque is basically your moment is about a point. Okay, so what is that point? 2 point. So you have to write that moment of force about point. So that point you have to mark over. MO. MO means what? O is the point about which you are taking the moment. That is equal to how much? A into D. Okay, and all, so this will be the magnitude part. And what is the direction of rotation? And I say the direction of rotation is anti-clockwise. So the force has the tendency that the body will rotate about this pivot point in anti-clockwise direction. Okay, so until and unless I pass the force, I allow the force to be there, and if the moment is there, then only I can rotate. So when the moment can be 0, if this D number is equals to 0, then moment is 0. So D number is equal to 0 means that force must pass through this point. So if I allow this force to pass through this point, then there is no perpendicular distance between point P and O. The point P is lying on O itself. Okay. In that situation, there is no distance, that means D number becomes 0. And in that situation, that force has no responsibility to produce any kind of turning effect. So what it produces, it can produce only translated. Okay. So whether the moment is there or not, depending on that, I can conclude that whether the body will rotate or not. If moment is there, then I can say the body is rotating. If moment is not there, that means I can say body is not rotating. And with the effect of force, the body may translate may, depending on how much amount of friction is there. Okay. So this is called the rotation effect. So rotation may be either clockwise or anti-clockwise. There are two directions. Okay. So let us say there is a wheel. On this point, I am applying a force in this direction. Okay. So about point 2, you have to take the moment. So if I place my pencil along this A direction, and I have to rotate this pencil towards this direction. So I have to rotate in this direction. Okay. So that means I am rotating in this direction, means this is the 90 degree angle. So every time you have to look for the small value of the angle. You can also rotate the pencil through the other angle also. You can rotate in this direction. So that again the pencil is making towards O direction. But I don't consider this angle. I consider this angle. Smaller angle is along this clockwise direction. So this force will produce a rotation in the clockwise direction. So we will rotate in the clockwise. Similarly, if I say, let us say I am applying a force in this direction. F in this direction. So O is this. So pencil is pointed upward, vertically upward. No, pointed upward. So you have to make this pencil in this direction. That means you are rotating in this direction. So it is anti-clockwise. So the body rotates in the anti-clockwise direction. Okay. So this turning effect may be either anti-clockwise or clockwise. If I say clockwise moment is positive, then you should say that anti-clockwise moment is negative. So if a multiple force is acting, let us say there is a body on the radius, let us say 2 meters. In the point, at this point you are applying a force of 20 Newton. At this point you are applying a force of, let us say, 5 Newton. Okay. So 20 Newton is giving a clockwise moment. 20 Newton is giving a clockwise moment. So what is the moment of 20 Newton? 20 into 2. So 40. Okay. And what is the unit? That is Newton into meter. Okay. If I say this number is positive, then 5 is giving the anti-clockwise moment. So minus 5 into 2, that means 10. Okay. So ultimately I am getting 30 Newton meter in clockwise direction. Okay. So effect of these two forces is such that the body will rotate in the clockwise. Okay. So you have to decide in which direction is rotating. That means you have to take the net moment. So what I am taking the net moment. Okay. So net moment is the summation of all the moments about the same point. So let us say there are multiple number of forces are existing. F1 is the force. F2 is another type of force. F3 is another force. So multiple number of forces are there. So for multiple force system, every time you have to take the net moment about point 2. So net moment about point 2 is the summation of all the moment of different forces about point 2. So first we take the moment of, let us say, force F1 about point 2. Then if we take the moment of F2 about point 2, like this, you have to add all the, and whenever I am doing the addition, you have to take the direction. One direction may be positive, another direction may be negative. Any direction you can take positive, so other direction should be negative. Like this way, you have to take the total moment. And if the total moment coming to be non-zero number, let us say once I take the net moment, if this number is not equal to 0, that means the body will rotate. Okay, depending on the sign you have assigned, whether you are getting positive number or negative number, according to that direction the body will rotate. If you are getting the net moment to be 0, then I say the body will not rotate. And whenever there is no rotation, then I say the body will be in rotational equilibrium. It is called the rotational equilibrium. So what is equilibrium? Equilibrium is no rotation. No rotation. So whenever the body is in rotational equilibrium, that means net moment about point 2 should be equal to 0. Okay. And if net force is 0, then it becomes translation equilibrium. Net force is 0 means translation equilibrium. Net moment is 0 means rotational equilibrium. So depending on that, the body may be either in equilibrium or not in equilibrium. Okay. So let us say there is a door, you want to open the door. No, whenever you are opening the door, that means you are applying force on the door knob, and because of that, a turning effect is being produced, and according to that, the body will open on. Now, in this particular situation, the door is about to rotate about this axis. Okay. So this is the axis about which the door is rotating. Why? Because on this axis, door are fixed at these 2 points. These points which are fixed, they are not allowed to rotate and known as the hinge point. The hinge. Okay. About hinge, the body is rotating. That means once we apply a force, let us say we apply a force in this direction. In order to open the door, we are applying a force in this direction. So once we apply a force in this direction, then the body will rotate because of this force. So what is the direction? This is the d distance. Okay. Because with the d distance, the body will rotate. Okay. The moment that you are applying on this particular door is basically F into d. Okay. The point where you are applying the force is the P point. Here is the P point, and this is the O point. The distance between P and O is the d number. So every time you have to identify what is the d number, there is a perpendicular distance, and depending on that only you can apply the moment value or you can calculate that. Okay. So similarly, steering wheel. So once you steer the wheel, that means either you can steer it in both hands or with the single hand. But whenever you are applying a force, let us say this is the wheel, and you want to rotate in this direction. Okay, you want to rotate in this direction. That means you have to produce an anti-clockwise one. Yeah, about this point 2. So that means if you apply a force in this direction, then the body will rotate. Okay, if you apply a force in this direction, the body will rotate. If you hold it by both the hands, let us say on you are driving a car by keeping the wheel to be fixed with both the hands. So that means you are applying another force F2 on this particular side also. And here is F1. So in order to get the overall effect, so F2 will produce the clockwise moment. F2 will produce the clockwise moment. And F1 is producing the anti-clockwise moment. And if you want to turn the car, let us say you are willing to turn the car in this direction. In this direction, that means you should produce an anti-clockwise moment. Yeah. So that means F1 must be greater than F2. F1 must be greater than F2. Then only the car will turn in the left hand direction. So you want to turn the car in the right hand direction. That means F2 should be more. So depending on that, you have to understand on which direction you have to rotate, and accordingly you have to adjust your hand force so that you can rotate the car. So steering is a classical example where you are applying a force to rotate the entire car. Okay, that means you are applying the moment. With the effect of force, you can only transit. But once you are able to get the rotational effect, then you have to apply the moment. Same is the logic for the gear wheel fitted in the cycle. So wherever I am rotating a cycle wheel or paddle wheel, that means I am producing a moment. Okay. So the moment that I am producing is on the driver. So on the driver wheel, I am giving the moment. Why? Because this is the paddle. So on the paddle, I am applying the force. So this is the wheel. On wheel, the force paddle is there. On the paddle, I am applying the force. Because of this force, because of the big distance, the body is rotating in the direction. Okay, so the driver will be rotated by the drivers. Okay, and once the driver wheel starts to rotate, so with the driver wheel, with the chain, so with the chain mechanism, I am connecting another wheel that is called the sprocket. Because the driven wheel. So the driven wheel is being rotating because of this driver. The driver wheel is rotating the driven wheel, and with the driven wheel, the rear wheel is being connected. Hmm. If you view the cycle, so cycle rear wheel is connected to the driven wheel. So rear wheel is being driven by this sprocket. And what about the front wheel? So with the front wheel, no wheel or no gear is being connected. No, I am applying the force on the paddle. So paddle is moving the driver wheel. And once I rotate the driver wheel because the turning effect of the force, now with this chain mechanism, the rear wheel is being rotated. But what about the front wheel? There is no connection with the chain with the front wheel. So let us say you are moving the cycle in the forward direction. Okay. So for that, the rear wheel should rotate in this direction. Front wheel also rotate in this direction. Okay. Now who is driving the front wheel? Now the friction comes in. So in the road, the friction is there. In the road, the friction is there. So friction is applied in this direction. The friction is responsible to reduce the rotation. Okay. On a smooth road, you can't cycle. Yeah. If you want to ride your bicycle on an icy floor, you cannot. Why? Because in icy floor, the value of friction is so less that it cannot produce any kind of rotation in the front wheel. Okay. So everywhere, the front wheel is being rotating by the basically the friction. And rear wheel is being rotating by the driver mechanism. Okay. In automobile engine also, I am rotating the rear wheel. And front wheel is being rotating by the friction also. But in some situation, I want to give power to both the wheel. Okay, let us say in some situation, I am connecting the chain sprocket mechanism with the front wheel also. That means now I am giving the supply to both. Okay. Why? Because in some situation, the friction is not useful to rotate it properly. Okay. Like in case of hilly road. So army truck or army jeep, in that situation, they are running in a very rough areas. Okay. So in those situations, the power has to be supplied in both the front wheel as well as the rear wheel. So in that situation, those particular type of car are known as four-wheel. Four-wheel drive. So four-wheel drive mechanism is basically the mechanism where you are supplying the power to both front and the rear wheel. So whenever you go for the purchase of four-wheel drive, these are very costly. Okay. So that's why our automobiles are running in our city condition. They are only the two-wheel drive. Why two-wheel drive? Because it is called the power is given to the both the back side, not the front wheel. Okay. So if you want to give the power to front wheel also, then you have to cost large money. Okay. Involvement of cost is there. So that's why you prefer to use the only two-wheel drive. So in that situation, the friction is responsible. So in the front wheel, friction is applying the moment or the torque. Okay. Otherwise, it cannot rotate. Similarly, the case of spanner. So you want to open this nut. So for that, you are using a spanner. The spanner has a long handle. So L number is more. Then we apply a low amount of force when the turning moment about this O point is less. Okay. So moment about O is basically F into L. So either you can increase the F value or you can increase the L number so that you can get a large value. So in order to open the nut, if you use a small size spanner, then you have to move about you have to use more value of O. If you use a large spanner, then if the L value is larger, then you can use a smaller value of A to open it also. Okay. So this is the idea to apply the moment. So now we discuss about the couple. So another aspect of this is called the couple. The couple means two types of forces are there. Okay, so two inputs, both the equal forces. Let us say for this driving wheel situation, if I apply a force in this direction and if I apply a force in the direction, both are same. So then both the moment will be cancelled out. Okay, because this force will give the anti-clockwise moment, this force will give the clockwise moment, and this distance is basically r. This also r. So net moment about 0.2 is zero, so body is not rotating. Okay, so in order to produce the couple, so what you should do, you should produce two different forces of equal magnitude but opposite in direction. Okay. So one force is in this direction, another force must be in the other direction. Let us say I am applying a force in the opposite direction. So now these two forces will keep the couple about point. Why? Because this will give the anti-clockwise, this will also give that. Net moment about point 2 should be equal to 2 times F into. Okay. Or I can say F into 2R. What is 2R? 2R is nothing but the distance between the two forces. So not to produce the couple, two forces must be there. That's why the name is couple. And the two forces must be of equal magnitude and opposite in direction. And they should not pass through this O point. Because this is one P1 point through which the force is passing, this is another P2 point through which the force is passing. Both P1 P2 should be not coinciding with point 2. Okay, let us say I am saying this is a wheel. I am applying a force of, let us say, F1 over here, F over here, F over there. Opposite forces equal magnitude, but they are passing to the point 2. Okay, that means they are not giving any kind of couple. Okay, so in order to get the couple, the force must not coincide with the line of O. O is the point about which the body should rotate. Okay, so then only I can produce the couple. So couple is basically useful to produce different types of. When you open a tap, so basically you are giving it coupling. So the head of the tap is like this. So once you are opening the tap, you are applying a force in this direction, another force in this direction with your both the fingers. Okay. If you want to open it by one finger, that means you are applying only one single force, then the effort will be more. So in order to open the tap very easily, so you are applying two different forces of equal magnitude but in opposite direction. That means you are giving the couple effect. Because with couple effect, the body will rotate easily. Similarly, bottle opener. Whenever you try to open the bottle or open the lid, that means again you are applying. So in order to open this lid, again you are applying one force in this direction, another force in this direction. So that it will be opened easily. If you apply only one single force, it will be difficult to open. Okay, it will be difficult to open it. So couple is basically a factor which are using in daily life. In every situation, like opening a door. Okay. Again, so I am giving one force on this particular, so this is the key handle. So one force I am giving over here, another force giving over there. Okay. So two opposite forces are being used of same magnitude, so that gives the couple. So with the help of couple, I can open anything with very not less effect. That's why the couple is in there. So couple is basically giving a turning effect, not other than the moment. So it is similar to the moment effect, but with lot of easier. Now we discuss about equilibrium. So far we understand that in order to make the body to be equilibrium, there are two types of equilibrium. One is translation equilibrium. Yeah, whenever I am saying translation equilibrium, that means the net force should be equals to 0. Net force equals to 0. Okay. That means let us say there is a body. On this body, let us say there is a mass of, let us say, 2 kg. So 2 kg mass is there. You are applying a force of 10 Newton over here, and you are applying a force of 5 Newton over there. Okay. So what is the net force acting on this? Net force is 5 Newton along the positive acceleration here. So that number is not equal to 0. That means the body should not be equal. So what happens with this force? The body will try to move. So body will move. What is the acceleration? Acceleration force by mass. Okay. So 5 by 2, that means 2.5 meter per second square with acceleration, the body will move. Okay, that means it is not in equilibrium. In order to make it in equilibrium, this 5 Newton should be made to 10 Newtons. If I increase it to 10 Newton, then the net force should be reduced. If the net force is 0, now the body will be in equilibrium. That is, body will be in rest. So for translation equilibrium, you have to make sure that the net force on the body must be crossed. And since force is a vector quantity, so to add it with vector. Okay. Now second equilibrium is the rotational equilibrium. So for rotational equilibrium, net torque or net moment about the fixed point O must be equal to 0. Okay. Net moment about the fixed point must be 0. If I am getting not equal to 0 number, that means the body is rotating. That means body is not in equilibrium. Okay. So equilibrium are possible. Let us say I want to verify the principle of moment. That means using the equilibrium concept. So let us say there is this long scale is there, meter scale is there, and on one end at point B, you are supporting your weight of W2. Okay. So because of the W2, there is a tendency that the scale will bend in this direction. Okay. Now, in order to make sure that the scale remains in horizontal position, on the other end, you are putting another weight of W. Okay. So you want to adjust the position of W1 in such a way so that the length become horizontal. That means what you can conclude that since there is no rotation effect about the point 2, I can say the moment of W2 about point 2 must be equal to the moment of W1 about point 2. And what is the moment of W2 about point 2? It is W2 into L2. That should be in the which direction? Anti-clockwise direction. Okay. Plus W1 into L1. W1 into L1 and W1 L1 is the clockwise direction. That means we should put a negative sign in between these two. Okay. So that will be the net moment, and that moment, if it is zero, if this moment total moment is equals to zero, then only I can say that the body is in equilibrium. So in order to make it equilibrium, the condition is that W2 into L2 should be equal to W1 into L1. Now, from this equation, you can calculate what is the position of the L1, where you have to put the W1 so that the body will be in equilibrium. Okay. If L2 value is known, W2 is known, W1 is known, you can calculate easily the value of L1. That is, we can verify that the principal moment is acting over here, and once the net moment we are getting to be zero only, then only the body will be in the static situation or no rotational condition. No rotation means the body should be in the horizontal position. If I say that the moment of W2 is more, so moment of W2 more means the anti-clockwise moment is more. So then the body will be treated in the anti-clockwise direction. If the moment of W1 is more, then the body will be treated in the clockwise direction. So both are same, then only I can say the body is in equilibrium. Otherwise it is not. Okay. So in this equation, there is a wheel. It has a fixed axle passing through the point. So O is the point, there is a pivot point. The wheel is kept stationary under the action of a horizontal force. F1 is the horizontal force, and a vertical force F2 is there. So vertical force F2 at point B. Okay. So the direction of force F2 that should be in the diagram. Okay. At point B, in which direction the force has to be applied so that the body will be equilibrium. So F1 is giving a moment about point 2 in the clockwise direction. What is that moment? Let us see the R. So moment of F1 is F1 into R in clockwise direction. So for clockwise symbol, you put arrow like this. So this is the moment of force F1 about point 2. So in order to make the body to be in equilibrium, so there must be another force F2 that should give a moment about point 2 so that the body should be in equilibrium. So it should be in the clockwise moment. If I apply a force in this direction, let us say I am applying a force of F2 in this direction. So corresponding with F2 force, this is the talking distance D. Okay. So now this F2 into D will be the anti-clockwise moment. So it is the same direction. It is opposite direction. So minus F2 into D in the anti-clockwise direction is the zero moment. It is possible. And if this is possible, that means I can say the body is equal. So vertical force F2 should be downward. Okay. So your first question is the direction of the F2 in the diagram. Now which of the force F1 or F2 is greater? Now we know that F1 into R should be equals to F2 into D. Okay. So F2 equals to how much? F2 equals to F1 into R by D. Now clearly from the diagram it has been known that R number is more than D now. So D is what? O prime number. So since D is less, F2 is more. That means F2 should be more than F1. Generally the body should be in equilibrium. Okay. Now the values are given. Ratio between F1 and F2. AO is 2.5 centimeter. AO means R. So your R value is 2.5 centimeter given. And BO prime is given as 1.5 centimeter. So BO prime is 1.5 centimeter and O prime O is 2 centimeter. That means this is your D number. Okay. The D number is 2 centimeter. So you are asked to calculate the ratio of F1 by F2. What is F1 by F2? F1 by F2 is equals to what? D by R number. So D is 2, R is 2.5. Okay, 20 by 25. Okay, 4 by 5. So ratio is 4 by 5. Okay. So if you maintain that particular ratio, then only the body will be in equilibrium. That means you have to make the force be vertically downward so that you can produce the opposite direction moment, because The direction of moment for F1 is known. The only thing is that you have to give the direction of F2 in proper way so that the net moment should cancel. So if I say one moment is positive, another moment must be negative. Okay, so F2 should be vertically down. Like this way. So there are two parallel and opposite forces, F1 and F2. So one force is F1, another force is F2. So these two are parallel forces and opposite magnitude, same magnitude, opposite direction. Okay. Now, each of 5 meters with the line of force separated by distance of 2 meters. So this is the d distance between them. Okay. So a point X lies midway between F1 and F2. So this point is lying in between F1 and F2. Okay. Calculate the total moment of the two forces about the point X and Y. Y is on this point. Now, one thing you have to remember that once you calculate the moment, if there is no gap between the point P and B, let us say, if I say this is a force and this is the point P and this is the point 2. So you can say this is the perpendicular distance. If the point O is lying on the force, let us say this is A and point O is over this point. That means this particular situation gives a 0 moment. Okay. Why? Because P and O are on the same line. P is the point where I am applying the force and O is the point about which I have to take the moment. If point P and O lie in the same line, then the moment will be 0. So once we calculate the moment about point X, let us say this distance is A. Okay, so this distance should be how much? 2 minus A. 2 minus. So moment of F2 about point A should, so you have to place your pencil in this direction, so you have to rotate in this direction. That means you are rotating in the clockwise direction. So moment of F2 is clockwise, and similarly moment of F1, so F1 is over there, you have to make the F1 to be there, that means you have to rotate in clockwise direction. Okay, so both are clockwise, that means both the moment will be added up. Both are clockwise, that means both the moment should be added up. So for F2, moment is how much? 5 into 2 minus A. For F1, it should be 5 into A. Okay, so ultimately how much? Is 10 Newton into Newton. Okay, so about X1. Now similarly about Y point, if I want to calculate, so moment of F2 will be 0. Moment of F2 will be 0 because Y is lying on it. Only the moment of F1 will come. So now the distance is about 2 meter total distance. So about point Y, My is again I am getting 10 Newton. 10 Newton. Okay. So state the effect produced by the two forces about the point X and Y. So entire moment that I am getting in the clockwise direction. Entire moment I am getting in the clockwise direction. So what is the effect? Effect is that about point A, the force will try to rotate the body in this clockwise direction. Okay. So about point Y, so F2 is not able to rotate. So only F1 is rotating. Because if F2 has 0 moment, so F1 will rotate about point Y, but again in the clockwise direction. Okay. So what you learn from this exercise is that this is an example of couple. Why? Because one force of magnitude of 5 Newton is acting towards right, another force of same magnitude of 5 Newton towards left. So for couple, so only the distance between these 2 points will matter. Okay. So product of F into D will give the moment. Okay. About any, whether the point is on the F2 line or whether the point is in between or point is over here, at any point you can take the moment, the answer is the same. Okay. The moment value does not depend on the location of the point. It is basically dependent on the distance of separation between the two forces. If I keep the D number to be fixed one, then every time I am getting the same value. There is no change in the moment value. Okay. F into D, every time I am getting the same answer. Okay. Now there is the uniform meter rule placed horizontally on a knife edge. Now what is knife edge? Knife is basically support. A symbol of knife is like this. So uniform meter rule is supported on knife is like this. Meter rule means total length of the rule is 1 meter, that is 100 centimeter. At the 60 centimeter mark, when a mass of 10 gram is suspended from one end, draw a diagram of the arrangement. Okay. So let us say this is a 0 point mark. Let us say this is a 60 point mark, 60 centimeter mark. You are putting one weight at this position. Okay. You are putting a mass of 10 gram at this point. So this is the diagram basically. Okay. Now, at which end must this mass be suspended so that it becomes horizontal? Okay, so that it becomes horizontal. Now, in order to make the scale to be horizontal, if I place the mass over here, then there is a tendency of this mass to produce a moment about 0.2. No, tendency of mass to provide a moment about 0.2. That means the scale is not horizontal. So in order to make the scale to be horizontal, you have to consider the another moment. Okay, so only one moment cannot be the zero answer. So you have to give another moment. Now, who is responsible to produce another moment? There is a knife, the meter scale also. So meter scale has some kind of mass. So you are asked to calculate the mass of this rule. So let us say mass of the rule is m. Now where is the mass of the rule is pointed? That mass of the rule should be pointed at the midpoint at the 50 centimeter. So that means if I redraw this is the scale at the 50 centimeter mark, the mass of the rule is acting, that is m is there. Okay. So that is giving a moment. Now 60 centimeter mark is over here. 60 centimeter mark is over here. So here I am giving the 10 mass. So that in order to make the moment to be zero, the knife edge has to be satisfied over here at this position. So here you have to put your stop. Then only the moment will be cancelled out. So let us say in between these two there is a gap of x. Okay. In between these two there is a gap of x. So what is the other gap? Other length is basically 10 minus 6, because 50 to 60 is 10 centimeter. So 10 minus 6, this number is 10 minus 6. Okay. So in order to give a zero moment, so the knife edge has to be placed between 50 and 60 centimeter mark. Knife edge has to be placed between the 50 and 60 centimeter mark. Understood? Now regarding the mass of the rule, so net moment about this point should be 0. What is the net moment? So this m is giving one moment, this 10 is giving another moment. What is the moment of m? M into x. What is the moment of the 10? That is 10 into 10 minus 6. Okay. So once I know the value of x, then only I can calculate it. Once I know the position of the line, so m should be how much? M should be 10 into 10 minus 6 by x. Okay. So if I say x is placed at 5 cm, and exactly at the midpoint between this 50 and 60, let us say I am placing this edge at 5 cm distance. This is the 5 cm distance. Okay. So if I place it at 5 cm, then 10 minus 5 is 5. 5. So that m should be 10 gram there. Okay. Both the mass of the rule and the mass of the weight that you are suspending, both should be same. If I make it not 5, it is 6 or 7 or any other number, then the mass will be different. Okay. So the mass of the rule depends on the position where I am placing the knife. If the knife edge is exactly placed between the 50 and 60 centimeter mark, then the mass of the rule is nothing but the mass of the weight that has been suspended. Okay. Now similarly, you can do this type of situation. Okay. I am not going into the detail of this. About the center of gravity. Now center of gravity is another thing that you have to understand, that this is defined for a body which is not point object, which is distributed object. This type of bodies are called the distributed. Why? Because the mass is not concentrated at a particular. Okay. If I draw a point, that means the entire, let us say this point mass having 10 kg. That is within a point mass. If I say this is the entire mass, whose mass is also 10 kg, that means now I want to give the feeling that if I want to replace this by a single point mark, where should we mark that particular? That point may be within the body, may be outside the body. Okay. So center of gravity is a concept which gives that this is a point about which the total weight is there. What are the individual? Let us say I am saying the entire weight, entire body, let us say mass is 10 kg. You divide this 10 kg mass into small part. Yeah, you divide the mass into small part of, let us say, 1 gram. Okay, 1 gram each. So you make 1,000 of pieces of this entire mass, and for each mass I can say now these masses are behaving as a simple point mass. So for this point mass, this is 1 point mass, let us say, the other point mass. So all the point masses are there. And what is the effect of this point mass? The effect of this point mass is I want to replace the entire point mass by a single mass which has to be placed at a point known as G. This G is known as the center. Okay. Now G may be within the body, may be outside the body. So there are some regular shaped objects for which you should know what is the location of this G. So let us say this is a rod. So rod is the geometry of this kind of situation. This is the rod. So rod is basically G is at a midpoint of the axis. Okay. So if I see this total length is L, so at L by 2 distance, from both the end, the G has to be, and that rod is said to be uniform rod. Uniform means the density is constant. If the rod is not uniform, that the density of the material is varying, so then it should not be at the midpoint. Okay. Every time, whenever I am saying the disk, let us say disk, if the disk is uniform density, then only it will be at the center, geometric center. If I say this is a disk, so center is O point. So O is basically our G point. So through this G point or through this O point, the resultant weight is there. Okay. Similarly, solid sphere or hollow sphere, geometric center. Solid or hollow cylinder, midpoint of the axis. Let us say this is the cylinder. So for cylinder, let us say the height h. So at this point, so this is the h by 2 distance from the bottom, the center of gravity should lie, and they should lie on this axis. Okay. Solid cone, that is h by 4 from the base. Solid cone is h by 4, hollow cone is h by 3. Okay. What is h? It is the height of the cone. Similarly, circular ring again center. Triangular lamina. Lamina is the intersection of the median. The intersection of the median. Whenever I am saying triangle, so for triangle you have to draw 3 medians. So this is one median, this is another median, this is another median. So the intersection of the median will give the intersection point of the G point or the center of gravity point. Similarly, parallelogram or rectangular intersection of diagonal. Okay. So like this way you have get the value of position of the G point from the regular shape geometry. These are only valid for the regular shape geometry. That means whenever I am saying the material having the constant density. If the density is constant, then only I can say these are the location of the central gravity. If the density is not same, then I can say that G is not same. G will be different. G will be different at different location. Okay. So these are the different positions that we have already said that there is circular ring, circular disc, triangular lamina. Now regarding the triangle, you should also remember that this height, if I say this is the h dimension, then this height should be h by 3. And this is 2h by 3. That means G is dividing the entire median into 2:1 ratio. 2:1 ratio. Upper part is 2 part, lower part is one part. Okay, so 2:1 ratio will divide the entire G. So from the bottommost position, this G should be equal to h by 3. Now, rectangle, parallelogram, square, all are the intersection of the diagram. All are the intersection of the diagram. Rod, cylinders, like this. Now, why this is important? Center of gravity is why it is important? Because it gives the idea of the balance. Now, what is balance point? Balance point is that you want to make a particular thing in balance condition. That means you should make it in original position. So there is a hammer. Let us say there is a hammer, and for the hammer, I know that heavier the mass is concentrated over here because this part is made of metal. Hard metal is there. A handle is made of wood. So more the mass means center of gravity will be shifted toward the higher mass. So let us say this is the G position of the hammer. So it should not be at the midpoint. Because this part is mostly made of wood material, less density material. So mostly the G will be shifted toward the heavier mass point. So that is the G location. If you place your thumb or finger at this location, that means you are applying a force at there. That means with this particular tip of the finger, you can balance the entire. That means once the object has to be balanced, that means it has to be made in zero moment. That means you have to put the support at this. Why? Because once I am saying it has to be the object. It is the object. Okay. It has to be the G location. So from this G, the entire weight is acting. Okay. So if I balance over here, O point, that is about O, the W will give moment. Okay. So if about O, the W is giving the moment, that means it should not be the balance condition. So you have to make the O point should be over here. That means you have to give another support over here. That means you are giving suppose F. That means A for W will be the zero moment about O. That means it will be in the balance situation. Okay. Like this, there is a doll. The doll is heavier at the bottommost position. This is the heavier part. So center of gravity will be lying in the bottom part. Okay. Once you tilt the doll, let us say you draw a vertical line So center of gravity is passing through vertical. About the axial symmetry. Once you tilt it, so G will shift it toward that direction. Okay, let us say this is a vertical line. Initially there is a G location. Now if she make it rectangular, so G goes to this direction. G goes to this direction. So now the weight is acting downward to this point. Okay, to this point. Okay, so if I tilt it, so this weight has the ability to produce the moment about point 2 in clockwise direction. Ability to produce the moment about clockwise direction. So W is trying to make the object to be tilt more. Okay. So once you tilt it, so W is in the other direction. So W will try to make it fall further. But in order to prevent that, what you should do, you should give another type of moment in the opposite direction. So W is giving a clockwise, anti-clockwise. W is giving a anti-clockwise moment about point 2. Okay. So in order to make it clockwise movement, so in order to give clockwise movement, that means in order to move it back towards the vertical position, so you have to give clockwise movement. Okay, you have to give clockwise movement. So clockwise movement is being provided by the normal point, right? Because now the norm. So initially, this is the point of support. This is the point of support. Okay. So now the point of support is shifted over here. Okay. So if you closely look this position, so where this is the vertical line, this is the inclined position. So along with inclined, this is the G location, and now the body is being supported over here. This is the normal position, point where the normal force is acting. Okay. So the normal should be shifted away from the G position. Away from the G position. Let us do it properly. So let us say this is the inclined position. The G should be over here, so that the W is acting downward, and normal should be left of W. So the W is giving the clockwise movement, and normal is giving W is giving the anti-clockwise movement. Normal is supporting, providing clockwise movement. And because this normal shifted towards the left hand side, now the doll becomes taken vertical. Okay, it will not fall. Whether you try to tilt it further away, so let us say tilt up to this direction. Okay, so then the G will be over here. Let us say G will be over here. So normal will be shifted further. Normal is over here. So normal is always trying to pull the body to the vertical positioning. Okay, so due to the position of the shifting of the normal force as well as the gravity force, the body is said to be in the equilibrium. So that the balanced position again. Okay, so this is the idea of the torque or moment. Okay, now come to the next segment of this chapter is called the uniform circular motion. So regarding the circular motion, that means the particle is moving in a circle. So whenever I am saying circular motion, that means the particle must move along a circle. Okay. So if the particle is not changing its speed, let us say I am saying this is a particle circle moving along a circle, and at this point the speed is v, at this point the speed is v, at this point the speed is v. Every time the speed is v. Okay, if the speed is not changing, let us say the v is to say meter per second. So particle is moving along a circle whose center is O, but it is not changing its speed. But every time the direction of the vector velocity is changing. So in this situation, direction is in this direction, here the direction is here the direction is there. Okay, that is the velocity vector is changing in direction. So I say that speed is constant. Yeah, speed is constant, but the velocity is not constant. Okay, so since velocity is not constant, that means velocity is changing. That means the body must have some kind of acceleration. Without acceleration, the particle cannot perform circular motion. Okay, so whenever a particle is performing a circular motion, so for that situation, the velocity is every time change, direction is changing, though the particle is maintaining constant speed. If the particle is maintaining constant speed, then only I can say we call the uniform circular motion. That means in this situation, what is the omega number? Angular speed. Omega is called the angular speed, and that angular speed is equals to v divided by r. What is r? R is the radius of the circle. R is the radius of the circle. So I am saying the v number is constant and r is also constant. So v by r ratio is always constant. So if that is happening, that v by r ratio, that is omega is constant, that we call the uniform circular motion. Okay. So whenever the particle is performing a circular motion, So the particle may have the constant speed throughout, may not. If the particle has a constant speed throughout, then I can understand that the particle is changing its direction. So in this point, let us say this is the v direction. After some point of time, the particle comes over the v direction is changed. So that means there is change in direction of the velocity. So that means velocity vector is changing. That means there must be an act. Without acceleration, the particle cannot change its velocity. Every time, direction of rotating body and direction of rotation both are defined one. Direction of rotating body means we are saying that this is the particle. So direction of rotating, who is rotating? This particle is rotating. No, this particle is rotating. So direction of rotation is always fixed. So particle is rotating in the anti-clockwise direction, that is fixed. But the direction of rotating body, that means the body is moving in this direction, body is moving in this direction, body is changing direction. So their direction is changing every time. Both are two different words. Okay. If you say the direction of rotation, that is always fixed. Either it is clockwise or anti. But direction of motion, the particle is changing. Yes, it is changing every time. That's why I am saying that the velocity is going to be changing. Okay. Though the velocity, since velocity is a vector, na? Velocity is a vector, so a vector quantity has both magnitude and direction. Okay. Either you can change the magnitude or you can change the direction. In both the way the velocity vector can be changed. So in this situation, what I am changing, the direction has been changed. So I am changing the direction number. So once I change the direction, that means the vector is going to be changed. So velocity is changing, that means vector is changing, that means there must be some acceleration. Now in this situation, though the speed is constant, but the acceleration is there. Now that acceleration which is there is acting always toward the center. Let us say A is the point of the particle. At that instant, what is the direction of acceleration? The direction of acceleration is towards the center. Just after some point of time, B is the location of the particle. So at point B, again the acceleration is towards the center. At point C, acceleration is towards the center. Every time the acceleration is towards the center. Now toward the center acceleration is called the radial acceleration AR. Okay. AR is called the radial acceleration. And radial acceleration has another name, is called the centripetal acceleration. What centripetal means? Towards the center. Okay. So a rotating body performing a uniform circular motion should always have a value of AR. Why? Without AR, particle cannot rotate. Now, if I go somewhat deep or inside the AR number, so AR value, if I calculate it, AR is equal to omega square into R or equals to V square by U. Okay. So, if the particle is rotating, that means omega cannot be 0. Nah. If the particle is rotating, that means omega cannot be 0. See, omega cannot be 0, that means AR cannot be 0. Okay. So, for a uniform circular motion, since omega is constant, so AR number is constant. Can I say that? AR number is constant. But magnitude wise it is constant, and vector wise it is different. Why? Because every time the particle is changing its direction, AR is also going to be changed. Okay. So here the AR is in this direction. After some point of here changes direction. So I should say that AR magnitude mod of AR or magnitude of AR, that is constant. Okay. But AR vector is not equals to constant. Okay. D, that is the magnitude, D vector magnitude or speed equals to constant. That is true. But E vector is not equals to constant. Understood my point? Because both D vector and AR vector are changing direction. Though their magnitude remain fixed. Because there are the vector quantity, if they are changing its magnitude, then also it may change. Or if they are changing their direction, then also it will change. So in this particular situation, they are changing their direction. Okay. So since the direction has been changed, that means what I can say that the vectors are always changing. Okay. So like this way, let us say this person is performing a circular motion. This person is performing a circular motion. So you can feel that. So it will go in this direction, then ultimately come back. So it will complete a circle. It will complete a circle. So starting from this point, it will rotate the entire circle. So the particle can perform the complete circle or partial circle. So here also the particles are rotating in a circular motion. Okay. So the difference between this circle and that circle is that in this particular system, the particle is performing a vertical circle. Because of this vertical circle motion. Okay. Because circle is vertical. So whenever the vertical circle motion comes in the picture, then the weight of the person is coming in the picture. Because the particle has a weight mg acting downward every time. Okay, then the effect of gravity comes into the picture. But whenever the particle is performing a circular motion of this kind, here it is called the horizontal circular motion. Why? Because this is the axis. About this axis, these are the different circles that I can draw. Okay, so all the particles are performing horizontal circular motion. Okay, so in horizontal circular motion, there is no effect of gravity. So gravity is acting in one plane and particle is performing in the particular plane. Okay, so no effect of gravity is considered in the horizontal circular motion, but the effect of gravity has to be considered for the vertical circular motion. Okay, now it gives the idea of the centripetal and centrifugal. Why? Because from the idea of the Newton's law of motion, what I can say that whenever there is a acceleration, let us say there is a body whose mass is m, and I am saying the body is moving with an acceleration. So in order to produce that acceleration, there must be some force. What is that force? That is equal to mass into acceleration. Okay, that force must be there. Similarly, what you understand that whenever the particle is performing a circular motion, so I say there is a radial acceleration. Yeah, there is a radial acceleration. So in order to provide that radial acceleration, there must be one force. Okay. So in order to provide the radial acceleration, there must be one force. The force which is supporting the radial acceleration is called the centripetal force. Okay. Now so if I say, let us say there is a body on this, let us say the force of 10 Newton is acting. Can the body in equilibrium? No. So body will translate. No, body will translate. So in order to make the body should be in equilibrium, so you have to apply an opposite force also. Okay. So the force which is acting toward the center is called centripetal force, and force which is acting opposite to the center is called centripetal force, centrifugal. One is the centripetal, one is the centrifugal. Okay. So both are of same magnitude. Both are of same magnitude. And the centripetal is balanced by the centrifugal force so that the body is equilibrium. So there are two effects of forces. Let us say you rotate this ball inside a spherical jar. So what happens? The ball will perform different types of circular motion. Let us say the ball are performing circular motion. So whenever the balls are performing circular motion, that means there must be one force acting towards the center. There is one force acting away from the center. This is the center of the circle. Let us say the force which is acting towards the center is basically centripetal. In centripetal, the force which is acting away from the center is the centrifugal. So both are acting simultaneously. Both are acting simultaneously. Let us say there is a atom. So inside the atom there is a nucleus part, positive charge. So surrounding that nucleus, the electrons are rotating. Okay, electrons are rotating. So electrons are of negative charge. So these two charges are attracted by the electrostatic force. Okay, so that force is acting towards the center. That means it is a kind of force which is the centripetal force. Now, in order to get that centripetal force, so the particle must have some kind of velocity. In the velocity, the electrons are rotating. So it has to be balanced by some other force which is directed away from the axis center to be the centrifugal force. Okay. So centrifugal force expression is what? Centrifugal force is always equals to m into air. Okay. M into air. That is the basically centrifugal force and in the Newton's law. Mass into acceleration. What is mass? Mass is mass. What is air? Air has two expressions. Either I can write omega square by r, or I can write a into v square by r. So omega square into r. Omega square into r or v square by r. Okay. So these are the two expressions of centrifugal force. And centripetal force may be provided by different types of nature. So in this situation, what you understand, the electrostatic force is acting on the centripetal force. Let us say there is a sun. About the sun, the earth is orbiting. Now there is no electrostatic force. Now the force is basically the gravitational force. Force of attraction due to gravity. So gravity is giving the centripetal force. And away from this, the centrifugal force is there. The expression of centrifugal force is always either mv square by r or m omega square. There is no change. But the expression of the centripetal force is different. It depends on the situation. In this particular example, the particle is touching the surface, so centripetal force is given by the normal. Let us say this is a hemispherical ball. So inside the pole, you are dropping a particle. So particle perform like this, go down like this. So when the particle is coming down, it is performing a part of the circuit. Yeah, part of the circuit. So since the particle is making contact with the surface, so the surface is providing a normal. The normal is acting towards the center of it. So this normal force is acting as a centripetal. Okay. So there are various types of forces that are responsible to produce a centripetal force. So expression of the centripetal force will differ depending on the situation to situation. In this situation, the centripetal force is the gravity force, as I have already said. Okay. So planets are orbiting about our sun. So all the planets are feeling a centrifugal force and centripetal force. The centripetal force is toward the center. Okay. Similarly, the spinning wheel. In the spinning wheel also, the wheels are facing the both type of force, centrifugal and centripetal. Okay. Okay. So whenever the centrifugal force comes into the picture, you have to be careful about the choice of the force. Okay. So whenever the two forces are there, let us say particle is performing a uniform circle. Let us say the spinning wheel is rotating with constant omega. Omega is constant. So if the omega number is constant, then only I can say it is performing uniform circular motion. Now, for uniform circular motion, when the particle performs uniform circular motion, so that is omega is constant. So for that, can I say that m omega square r, this number is equals to constant? Nah. And that number is basically the centrifugal force. So centrifugal force becomes constant, fixed constant. So that means it has to be balanced. Let us say you calculate this number, you are getting a value of 20 newton. Okay. So for this particle, which is performing circular motion, so about point 2, you observe there is one force that is 20 newton acting. Now the particle is performing a circular track. It is moving along a circular track. That means there must be another force which has to balance this thing. So the force which is balancing it, that must be the equals to 20 newton. Okay. Now the force which is balancing it, it should always be directed towards the center of the circle. That means this force must be a centripetal force. Okay. So that centripetal force arises due to either tension or normal or friction. Depending on the situation to situation, the nature of the force will vary. The nature of the centripetal force will vary. So according to that, the centripetal force comes into the picture. Without the centripetal force, the particle again cannot perform circular motion. Why? Because I know that whenever the particle is performing a circular motion, so every time the acceleration has to be there towards the center. The air has to be there. So in order to get that air number, there must be one force acting toward the air number. Okay. So otherwise the acceleration will not be produced. So since air is essential, that means the force which is producing that air, that is also essential. Okay, that means centripetal force comes into the picture. Without the centripetal force, the particle cannot perform a circular motion. That's true. Okay. This is all about the